Find the domain of the rational function f of x equals x divided by x squared plus x. The domain is all values of x such that the denominator is not equal to 0. The denominator cannot be equal to 0 because you cannot divide by 0. Set the denominator equal to 0 and solve for x. X squared plus x equals 0. Factor an x out of the left side of this equation. X times the quantity x plus 1 equals 0. If either x or the quantity x plus 1 were equal to 0, then the entire left side of the equation would be equal to 0. Set each factor equal to 0 and solve for x. X equals 0 and x plus 1 equals 0. In the second equation, subtract 1 from each side. X equals negative 1. If x equals 0 or x equals negative 1, the denominator is equal to 0. So the domain is all real numbers x such that x is not equal to 0 and x is not equal to negative 1. Find the domain of the rational function f of x equals x squared plus 4x divided by x squared minus 4. The domain is all values of x such that the denominator does not equal 0. The denominator cannot be equal to 0 because then you would be dividing by 0 and the function would be undefined. Set the denominator equal to 0 and solve for x. X squared minus 4 equals 0. Add 4 to each side. X squared equals 4. Take the square root of each side. X equals positive or negative 2. The 2 can be either positive or negative, because positive 2 squared equals 4 and negative 2 squared equals 4. So the domain is all real numbers x such that x does not equal positive or negative 2. Simplify the rational expression 9y squared divided by 6y. Write each factor as its prime factors. 9y squared equals 3 times 3 times y, and 6y equals 2 times 3 times y. There is a 3 and a y in both the numerator and denominator, so they cancel out. You are left with 3y divided by 2. This expression has to have the same domain as the original expression. In the original expression, there was a y in the denominator, so y cannot be equal to 0. The simplified expression is 3y divided by 2, where y is not equal to 0. Simplify the rational expression 6u to the 4th power times v cubed divided by 15 times u times v cubed. Write each factor as its prime factors. There is a 3, a u, and 3 v's in both the numerator and denominator, so they all cancel out. You are left with 2u cubed divided by 5. This expression has to have the same domain as the original expression. In the original expression, there is a u and a v in the denominator, so neither u or v can be equal to 0. The simplified expression is 2u cubed divided by 5, where v is not equal to 0 and u is not equal to 0. Simplify the rational expression 4x squared minus 1 divided by x minus 2x squared. Start by factoring 4x squared minus 1 into 2x minus 1 and 2x plus 1, and factor an x out of the denominator. The quantity 2x minus 1 times the quantity 2x plus 1 divided by x times the quantity 1 minus 2x. Factor a negative 1 out of 1 minus 2x. The quantity 2x minus 1 times the quantity 2x plus 1 divided by negative x times the quantity 2x minus 1. There is a 2x minus 1 in both the numerator and denominator, so they cancel out. You are left with negative 2x plus 1 divided by x. This expression has to have the same domain as the original expression. In the original expression, there was a 2x minus 1 in the denominator. 2x minus 1 cannot be equal to 0. Set this equal to 0 and solve for x. 2x minus 1 equals 0. Add 1 to each side. 2x equals 1. Divide each side by 2. X equals 1/2. The simplified expression is negative 2x plus 1 divided by x, where x is not equal to 1/2. Simplify the rational expression. The quantity z plus 3 squared divided by 2z squared plus 5z minus 3. Write the quantity z plus 3 squared as the quantity z plus 3 times the quantity z plus 3, and factor 2z squared plus 5z minus 3 into 2z minus 1 and z plus 3. There is a z plus 3 in both the numerator and denominator, so they cancel out. You are left with z plus 3 divided by 2z minus 1. This expression has to have the same domain as the original expression. In the original expression, there is a z plus 3 in the denominator, so z plus 3 cannot be equal to 0. Set z plus 3 equal to 0 and solve for z. Subtract 3 from each side. Z equals negative 3. The simplified expression is z plus 3 divided by 2z minus 1, where z is not equal to negative 3. Simplify the rational expression. 5a squared b plus 3ab cubed divided by a squared times b squared. Factor an a times b out of the numerator and write a squared b squared as a times b times b. There is an a and a b in both the numerator and denominator, so they cancel out. You are left with 5a plus 3b squared divided by a times b. This expression has to have the same domain as the original expression. The denominator of this expression has all of the same factors as the denominator of the original expression, so they already have the same domain. Simplify the rational expression. 2mn squared minus n cubed divided by 2m squared plus mn minus n squared. Factor n squared out of the numerator and factor the denominator into 2m minus n and m plus n. There's a 2m minus n in both the numerator and denominator, so they cancel out. You are left with n squared divided by m plus n. This expression has to have the same domain as the original expression. In the original expression, there was a 2m minus n in the denominator, so 2m minus n cannot be equal to 0. Set it equal to 0 and solve for m. 2m minus n equals 0. Add n to each side. 2m equals n. Divide each side by 2. M equals 1/2 n. The simplified expression is n squared divided by m plus n, where m is not equal to 1/2 n. Perform the indicated operations and simplify. 11t squared divided by 6 times 9 divided by 33t. Multiply the numerators and denominators together. 11 times 9 times t squared divided by 6 times 33 times t. Break each factor into its prime factors. There's an 11, 2 3's, and a t in both the numerator and denominator, so they cancel out. You are left with t divided by 2. This expression has to have the same domain as the original expression. In the original expression, there is a t in the denominator, so t cannot be equal to 0. Perform the indicated operations and simplify. the quantity x squared plus 2 times 5 divided by x squared minus 4. Multiply the numerators and denominators. For the factor x squared plus 2x, the numerator is x squared plus 2x, and the denominator is 1. The quantity x squared plus 2x times 5 divided by x squared minus 4. Factor an x out of x squared plus 2x, and factor x squared minus 4 into x plus 2 and x minus 2. There is an x plus 2 in both the numerator and denominator, so they cancel out. You are left with 5x divided by x minus 2. This expression has to have the same domain as the original expression. In the original expression, there was an x plus 2 in the denominator. So x plus 2 cannot be equal to 0. Set x plus 2 equal to 0 and solve for x. Subtract 2 from each side. X equals negative 2. The simplified expression is 5x divided by x minus 2, where x is not equal to negative 2. Perform the indicated operations and simplify. 4 divided by 3 times the quantity x minus 1 times 12x divided by 6 times the quantity x squared plus 2x minus 3. Multiply the numerators and denominators. Write each factor as the product of its prime factors, and factor x squared plus 2x minus 3 into x minus 1 and x plus 3. There is a 2 and a 3 in both the numerator and denominator, so they cancel out. Also, there are 2 x minus 1s in the denominator, which can be rewritten as the quantity x minus 1 squared. You are left with 8x divided by 3 times the quantity x minus 1 squared times the quantity x plus 3. Perform the indicated operations and simplify. 32z to the 4th power divided by 5x to the 5th power times y to the 5th power divided by 80z to the 5th power divided by 25 x to the 8th power times y to the 6th power. When dividing by a fraction, invert the divisor and multiply. Now multiply the numerators and denominators together. Write each factor as the product of its prime factors. There are 2 5s, 4 2s, 5 x's, 5 y's, and 4 z's in both the numerator and denominator, so they cancel out. You are left with 2x to the 3rd power times y divided by z. This expression has to have the same domain as the original expression. In the original expression, there was an x and a y in the denominator, so neither x nor y can be equal to 0. The simplified expression is 2x to the 3rd power times y divided by z, where x is not equal to 0 and y is not equal to 0. Perform the indicated operations and simplify. A minus b divided by 9a plus 9b divided by a squared minus b squared divided by a squared plus 2a plus 1. When dividing by a fraction, invert the divisor and multiply. Multiply the numerators and denominators. Factor a squared plus 2a plus 1 into the quantity a plus 1 times the quantity a plus 1. Factor 9 out of the quantity 9a plus 9b, and factor the quantity a squared minus b squared into the quantity a plus b and the quantity a minus b. There's an a minus b in both the numerator and denominator, so they cancel out. You are left with the quantity a plus 1 squared divided by 9 times the quantity a plus b squared. This expression has to have the same domain as the original expression. In the original expression, there is an a minus b in the denominator, so a minus b cannot be equal to 0. Also, before inverting the divisor, a squared plus 2a plus 1 was in the denominator. This factored into a plus 1 times a plus 1, so a plus 1 cannot be equal to 0. Set both of these factors equal to 0 and solve for a. a plus 1 equals 0. Subtract 1 from each side. A equals negative 1. A minus b equals 0. Add b to each side. A equals b. The simplified expression is the quantity a plus 1 squared times 9 times the quantity a plus b squared, where a is not equal to b and a is not equal to negative 1. Perform the indicated operations and simplify. 5u divided by 3 times the quantity u plus v times 2 times the quantity u squared minus v squared divided by 3v divided by 25u squared divided by 18 times the quantity u minus v. When dividing by a fraction, invert the divisor and multiply. Now multiply the numerators and denominators together. Factor u squared minus v squared into u plus v and u minus v. Write 18 as 2 times 3 times 3 and 25 as 5 times 5. There's a 5, a u, a 2, a u plus 3, and 2 3's in both the numerator and denominator, so they cancel out. You are left with 4 times the quantity u minus v squared divided by 5 times u times v. This expression has to have the same domain as the original expression. In the original expression, there was a u plus v in the denominator, so u plus v cannot be equal to 0. Also, before inverting the divisor, there was a u minus v in the denominator, so u minus v cannot be equal to 0. Set each of these equal to 0 and solve for u. U plus v equals 0. Subtract v from each side. U equals negative v. U minus v equals 0. Add v to each side. U equals v. The simplified expression is 4 times the quantity u minus v squared divided by 5uv, where u is not equal to positive or negative v. Perform the indicated operations and simplify. 5x minus 6 divided by x minus 2 plus 2x minus 5 divided by x minus 2. Because these two fractions have the same denominator, you can add the numerators together. You get 5x minus 6 plus 2x minus 5 divided by x minus 2. Combine like terms in the numerator. The simplified expression is 7x minus 11 divided by x minus 2. Perform the indicated operations and simplify. X divided by the quantity x squared minus 9 minus 4 times the quantity x minus 3 divided by the quantity x plus 3. In order to add or subtract fractions, they need to have the same denominator. Start by finding the least common denominator. The two denominators are x plus 3 and x squared minus 9. X squared minus 9 can be factored in x plus 3 and x minus 3. The least common denominator has to contain each factor. So the least common denominator has to be the product of x plus 3 and x minus 3, which equals x squared minus 9. The first term already has this as its denominator, so there's no need to do anything to it. Multiply the second term by the quantity x minus 3 divided by the quantity x minus 3. Multiply the numerators and denominators in the second term. Now that the denominators are the same, you can subtract the numerators. Now simplify this. Square the quantity x plus 3. Distribute the negative 4. You can combine like terms by adding the x and the 24x. You are left with negative 4x squared plus 25x minus 36 divided by x squared minus 9. Perform the indicated operations and simplify. X squared plus 2 divided by x squared minus x minus 2 plus 1 divided by x plus 1 minus x divided by x minus 2. To add and subtract fractions, they need to have the same denominator. Find the least common denominator. The three denominators are x squared minus x minus 2, x plus 1, and x minus 2. X squared minus x minus 2 can be factored into x plus 1 and x minus 2. The least common denominator has to have each of these factors. So the least common denominator is the quantity x plus 1 times quantity x minus 2. The first fraction already has this as its denominator. For the second fraction to have this as its denominator, multiply it by x minus 2 divided by x minus 2. And for the third fraction to have this as its denominator, multiply it by x plus 1 divided by x plus 1. Multiply the numerators and denominators together for 1 divided by x plus 1 times x minus 2 divided by x minus 2, and negative x divided by x minus 2 times x plus 1 divided by x plus 1. Each term has the same denominator, so you can add and subtract the numerators. The 2 and negative 2 cancel out. Distribute the negative x to the x plus 1. The x squared and negative x squared cancel out, and the x and negative x cancel out. You are left with 0 divided by the quantity x plus 1 times the quantity x minus 2, which equals 0. This expression has to have the same domain as the original expression. In the original expression, there is an x plus 1 and an x minus 2 in the denominator. So x plus 1 cannot be equal to 0, and x minus 2 cannot be equal to 0. Subtract 1 from each side in the first equation. X cannot be equal to negative 1. Add 2 to each side in the second equation. X cannot be equal to 2. The solution is 0, where x is not equal to negative 1, and x is not equal to 2. Perform the indicated operations and simplify. The quantity 9t squared divided by 3 minus t divided by the quantity 6t divided by t minus 3. There are fractions in both the numerator and denominator. So multiply both the numerator and denominator by the least common denominator of the two fractions. The two denominators are 3 minus t and t minus 3. T minus 3 equals negative 1 times the quantity 3 minus t. So the least common denominator is negative 1 times the quantity 3 minus t, or t minus 3. Multiply the numerators and denominators together. The t minus 3 in the numerator and the 3 minus t cancel out and leave a negative 1 left over. And the t minus 3 in the denominator and the last t minus 3 cancel out. You are left with negative 9t squared divided by 6t. Rewrite each factor as a product of its prime factors. There is a 3 and a t in both the numerator and denominator, so they cancel out. You are left with negative 3t divided by 2. This expression has to have the same domain as the original expression. In the original expression, there is a t minus 3 in the denominator, so t minus 3 cannot be equal to 0. There is also a t in the denominator, so t cannot be equal to 0. For t minus 3 cannot be equal to 0, add 3 to each side. T cannot be equal to 3. The solution is negative 3t divided by 2, where t is not equal to 0 and t is not equal to 3. Perform the indicated operations and simplify. The quantity 10 divided by x squared plus 2x divided by the quantity 15 divided by x squared plus 3x plus 2. There are fractions in both the numerator and denominator, so multiply both the numerator and denominator by the least common denominator of the two fractions. The two denominators are x squared plus 2x and x squared plus 3x plus 2. x squared plus 2x can be factored into x times the quantity x plus 2, and x squared plus 3x plus 2 can be factored into the quantity x plus 1 times the quantity x plus 2. The least common denominator has to be a product of each of these factors. The least common denominator is x times the quantity x plus 1 times the quantity x plus 2. Multiply both the numerator and denominator by the least common denominator. In the numerator, the x's and the x plus 2's cancel out. And in the denominator, the x plus 1's and the x plus 2's cancel out. You are left with 10 times the quantity x plus 1 divided by 15x. 10 factors into 5 times 2, and 15 factors into 5 times 3. There is a 5 in the numerator and denominator, so they cancel out. You are left with 2 times the quantity x plus 1 divided by 3x. This expression has to have the same domain as the original expression. In the original expression, there is an x plus 1 and an x plus 2 in the denominator, so x plus 1 cannot be equal to 0, and x plus 2 cannot be equal to 0. This means x cannot be equal to negative 1, and x cannot be equal to negative 2. The simplified expression is 2 times the quantity x plus 1 divided by 3x, where x is not equal to negative 1, and x is not equal to negative 2. Perform the indicated operations and simplify. 3x to the negative first power minus y to the negative first power divided by the quantity x minus y to the negative first power. Rewrite 3x to the negative first power as 3 divided by x, y to the negative first power as 1 divided by y, and the quantity x minus y to the negative first power as 1 divided by the quantity x minus y. There are fractions in both the numerator and denominator, so multiply both the numerator and denominator by the least common denominator of the fractions. The denominators are x, y, and x minus y. The least common denominator has to be the product of each factor. The least common denominator is x times y times the quantity x minus y. Multiply the numerators and denominators and distribute. In the first term in the numerator, the x's cancel out. In the second term in the numerator, the y's cancel out. And in the denominator, the x minus y's cancel out. You are left with 3y times the quantity x minus y minus x times the quantity x minus y divided by x times y. Factor the quantity x minus y out of the numerator. You are left with the quantity x minus y times the quantity 3y minus x divided by x times y. This expression has to have the same domain as the original expression. In the original expression, there was an x minus y in the denominator, so x minus y cannot be equal to 0. Add y to each side. X cannot be equal to y. The simplified expression is the quantity x minus y times the quantity 3y minus x divided by x times y, where x is not equal to y. You open a floral shop with a setup cost of $25,000. The cost of creating 1 dozen floral arrangements is $144. Write the total cost C as a function of x, the number of dozens of floral arrangements created. The total cost is the setup plus the price times the number of arrangements. The total cost is C. The price is $144. The number of arrangements is x. And the setup is $25,000. Substitute these values back into the verbal model. C equals 25,000 plus 144x. Write the average cost per dozen C bar equals C divided by x as a function of x, the number of dozens of floral arrangements created. Start by writing the verbal model. The average cost is the total cost divided by the number of arrangements. The average cost is C bar. the total cost is C, and the number of arrangements is X. So C bar equals 25,000 plus 144X divided by X. Find the value of C bar at 500. Substitute 500 into the equation for X. 25,000 plus 144 times 500 divided by 500. This equals 97,000 divided by 500, which equals $194. Determine the average of three real numbers, x, x divided by 2, and 2x divided by 3. To find the sum of a set of values, add up all the values and divide by the number of values. So the average is x plus x divided by 2 plus 2x divided by 3 divided by 3. There are fractions in the numerator, so multiply both the numerator and denominator by the least common denominator of these fractions. The denominators of x, x divided by 2, and 2x divided by 3 are 1, 2, and 3. The least common denominator has to be the product of each of these. So the least common denominator is 1 times 2 times 3, which is equal to 6. Multiply the expression by 6 divided by 6. Multiply and distribute. You have 6x plus 3x plus 4x divided by 18. Combine like terms. A simplified solution is 13x divided by 18. Find the domain of f of x equals x plus 1 divided by x squared minus 6x plus 5. The domain of a function is all points where the function is defined. This function is defined wherever the denominator is not equal to 0. So x squared minus 6x plus 5 cannot be equal to 0. X squared minus 6x plus 5 factors into x minus 1 and x minus 5. The left side of this equation is equal to 0 when either factor is equal to 0. Set each factor equal to 0 and solve for x. X minus 1 cannot be equal to 0, and x minus 5 cannot be equal to 0. For the first one, add 1 to each side. X cannot be equal to 1. For the second one, add 5 to each side. X cannot be equal to 5. So the domain of this function is negative infinity to 1, 1 to 5, and 5 to infinity. Simplify the rational expression. 4 minus 2x divided by x minus 2. Start by factoring a 2 out of the numerator. Negative 2 times the quantity x minus 2 divided by x minus 2. There is an x minus 2 in both the numerator and denominator, so they cancel out. You are left with negative 2. This expression has to have the same domain as the original expression. In the original expression, there was an x minus 2 in the denominator, so x minus 2 cannot be equal to 0. Add 2 to each side. X cannot be equal to negative 2. The simplified expression is negative 2, where x is not equal to negative 2. Simplify the rational expression. 2a squared minus 5a minus 12 divided by 5a minus 20. The numerator factors into 2a plus 3 and a minus 4, and you can factor a 5 out of the denominator. There's an a minus 4 in both the numerator and denominator, so they cancel out. You are left with 2a plus 3 divided by 5. This expression has to have the same domain as the original expression. In the original expression, there is an a minus 4 in the denominator, so a minus 4 cannot be equal to 0. Add 4 to each side. A cannot be equal to 4. The simplified expression is 2a plus 3 divided by 5, where a is not equal to 4. Find the least common multiple of x squared, 3x cubed, and the quantity x plus 4 squared. Start by finding the factors of each of these expressions. X squared is x times x. 3x cubed is 3 times x times x times x. And x plus 4 squared is the quantity x plus 4 times the quantity x plus 4. The least common multiple has to contain each of these factors. Note that there is an x times x in x squared, and an x times x in 3x cubed, so you only need to include the x times x once. The least common multiple is 3x cubed times the quantity x plus 4 squared. Perform the operation and simplify. 4z cubed divided by 5 times 25 divided by 12z squared. Multiply the numerators together and multiply the denominators together. Also, find the factors of each numerator and denominator. You have 4 times z times 5 divided by 5 times 4 times 3 times z times z. There is a 4, 2 z's, and a 5 in both the numerator and denominator, so they cancel out. You are left with 5z divided by 3. This expression has to have the same domain as the original expression. In the original expression, there was a z in the denominator, so z cannot be equal to 0. The simplified expression is 5z divided by 3, where z is not equal to 0. Perform the operation and simplify. Y squared plus 8y plus 16 divided by 2 times the quantity y minus 2 times 8y minus 16 divided by the quantity y plus 4 cubed. Multiply the numerators together and the denominators together. Y squared plus 8y plus 16 can be factored into y plus 4 squared, and 8 can be factored out of 8y minus 16, and that 8 can be written as 4 times 2. And y plus 4 cubed can be written as the quantity y plus 4 squared times the quantity y plus 4. There is a 2, a y plus 4 squared, and a y minus 2 in both the numerator and denominator, so they cancel out. You are left with 4 divided by the quantity y plus 4. This expression has to have the same domain as the original expression. In the original expression, there is a y minus 2 in the denominator, so y minus 2 cannot be equal to 0. Add 2 to each side. Y cannot be equal to 2. The simplified expression is 4 divided by y plus 4, where y is not equal to 2. Perform the operation and simplify. The quantity 2xy squared cubed divided by 15 divided by 12x cubed divided by 21. When dividing by a fraction, invert the divisor and multiply. Now multiply the numerators and denominators together. Cube the 2xy squared, factor 21 into 7 times 3, 15 into 5 times 3, and 12 into 4 times 3. There's a 4x cubed and 3 in both the numerator and denominator, so they cancel out. You are left with 14y to the 6th power divided by 15. This expression has to have the same domain as the original expression. There was an x in the denominator, so x cannot be equal to 0. The simplified expression is 14y to the 6th power divided by 15, where x is not equal to 0. Perform the operation and simplify. The quantity 4x squared minus 9 divided by 2x plus 3 divided by 2x squared minus x minus 3. When dividing by a fraction, invert the divisor and multiply. The quantity 4x squared minus 9 times the quantity 2x squared minus x minus 3 divided by the quantity 2x plus 3. The quantity 4x squared minus 9 factors into 2x minus 3 and 2x plus 3, and the quantity 2x squared minus x minus 3 factors into 2x minus 3 and x plus 1. There's a 2x plus 3 in both the numerator and denominator, so they cancel out. You are left with the quantity 2x minus 3 squared times the quantity x plus 1. This expression has to have the same domain as the original expression. In the original expression, the factors 2x plus 3, 2x minus 3, and x plus 1 were all in the denominator at one point. So none of these expressions can be equal to 0. For 2x plus 3 cannot be equal to 0, subtract 3 from each side. Now divide each side by 2. X cannot be equal to negative 3 halves. For 2x minus 3 equals 0, add 3 to each side. 2x cannot be equal to 3. Divide each side by 2. X cannot be equal to 3 halves. For x plus 1 cannot be equal to 0, subtract 1 from each side. X cannot be equal to negative 1. The simplified expression is the quantity 2x minus 3 squared times the quantity x plus 1, where x is not equal to negative 3 halves, or negative 1. Perform the operation and simplify. 3 divided by x minus 3 plus x minus 2 divided by x minus 3. These two fractions have the same denominator, so you can add the numerators together. You get 3 plus x minus 2 divided by x minus 3. Combine like terms in the numerator. The simplified expression is x plus 1 divided by x minus 3. Perform the operation and simplify. 2x plus 1 minus 4x squared divided by x plus 1. In order to add two fractions, they need to have the same denominator. 2x has a denominator of 1, and 1 minus 4x squared divided by x plus 1 has a denominator of x plus 1. The least common denominator is x plus 1. Multiply 2x by x plus 1 divided by x plus 1 so that it has the same denominator as the second fraction. Now multiply the 2x by the x plus 1 in the numerator. These two fractions have the same denominator, so you can add the numerators and combine like terms. The simplified expression is negative 2x squared plus 2x plus 1 divided by x plus 1. Perform the operation and simplify. 5x divided by x plus 2 minus 2 divided by x squared minus x minus 6. X squared minus x minus 6 factors into x minus 3 and x plus 2. In order to subtract fractions, they need to have the same denominator. The least common denominator is the quantity x plus 2 times the quantity x minus 3, so both fractions should have this as their denominator. Multiply the first fraction by the quantity x minus 3 divided by the quantity x minus 3. Now distribute the 5x to the quantity x minus 3. These two fractions now have the same denominator, so you can subtract the numerators. The simplified expression is 5x squared minus 15x minus 2 divided by the quantity x plus 2 times the quantity x minus 3. Perform the operation and simplify. 3 divided by x minus 5 divided by x squared plus 2x divided by x squared plus 2x plus 1. X squared plus 2x plus 1 can be factored into x plus 1 squared. In order to add and subtract fractions, they need to have the same denominator. Find the least common denominator. The three denominators are x, x squared, and the quantity x plus 1 squared. So the least common denominator is x squared times the quantity x plus 1 squared. Multiply 3 divided by x times the quantity x plus 1 squared divided by x times the quantity x plus 1 squared. Multiply 5 divided by x squared by the quantity x plus 1 squared divided by the quantity x plus 1 squared, and multiply 2x divided by the quantity x plus 1 squared by x squared divided by x squared, so that each fraction has the same denominator. Multiply the numerators and denominators, and square the x plus 1s. 3x times the quantity x squared plus 2x plus 1 minus 5 times the quantity x squared plus 2x plus 1 plus 2x cubed divided by x squared times the quantity x plus 1 squared. Distribute the 3x and the negative 5 to the quantities x squared plus 2x plus 1. Combine like terms. The simplified expression is 5x cubed plus x squared minus 7x minus 5 divided by x squared times the quantity x plus 1 squared. Perform the operation and simplify. The quantity 3x divided by x plus 2 divided by the quantity 12 divided by x cubed plus 2x squared. When dividing by a fraction, invert the divisor and multiply. Also factor an x squared out of x cubed plus 2x squared. You can now multiply the numerators and denominators. Factor 12 into 3 times 4. There is the quantity x plus 2 and a 3 in both the numerator and denominator, so they cancel out. You are left with x cubed divided by 4. This expression has to have the same domain as the original expression. Before inverting the divisor, x was a factor in the denominator, so x cannot be equal to 0. Also, there was an x plus 2 in the denominator of the original expression, so x plus 2 cannot be equal to 0. Subtract 2 from each side. X cannot be equal to negative 2. The simplified expression is x cubed divided by 4, where x is not equal to negative 2 and x is not equal to 0. Perform the operation and simplify. The quantity 9x minus 1 divided by x divided by the quantity 1 divided by x minus 3. Multiply both the numerator and denominator of the least common denominator of the fractions in the numerator and denominator. The fractions are 1 divided by x and 1 divided by x, so the least common denominator is x. Multiply the entire fraction by x divided by x. Now distribute the x. 9x times x minus 1 divided by x times x divided by 1 divided by x times x minus 3x. This simplifies to 9x squared minus 1 divided by 1 minus 3x. Factor 9x squared minus 1 into 3x plus 1 and 3x minus 1. Factor a negative 1 out of 1 minus 3x. The 3x minus 1 and the negative 1 plus 3x in the numerator and denominator cancel out. You are left with negative 3x plus 1. This expression has to have the same domain as the original expression. In the original expression, there was an x in the denominator, so x cannot be equal to 0. There is also 1 minus 3x in the denominator, so 1 minus 3x cannot be equal to 0. Add 3x to each side. 1 cannot be equal to 3x. Divide each side by 3. X cannot be equal to 1/3. The simplified expression is negative 3x plus 1, where x is not equal to 0 and x is not equal to 1/3. Perform the operation and simplify. The quantity 3 divided by x squared plus 1 divided by y divided by the quantity 1 divided by x plus y. There are fractions in the numerator and denominator, so multiply both the numerator and denominator by the least common denominator of these fractions. The three denominators are x squared, y, and the quantity x plus y, so the least common denominator is x squared times y times the quantity x plus y. Now distribute. 3y times the quantity x plus y plus x squared times the quantity x plus y divided by x squared times y. Factor an x plus y out of the numerator. The quantity 3y plus x squared times the quantity x plus y divided by x squared times y. This expression has to have the same domain as the original expression. In the original expression, there was an x plus y in the denominator, so x plus y cannot be equal to 0. Subtract y from each side. X cannot be equal to negative y. The simplified expression is the quantity 3y plus x squared times the quantity x plus y divided by x squared times y, where x is not equal to negative y. Perform the operation and simplify. 6x squared minus 4x plus 8 divided by 2x. Divide each term in the numerator by the denominator. 6x squared divided by 2x minus 4x divided by 2x plus 8 divided by 2x. Factor the terms in the numerators. 6x squared is factored into 2 times 3 times x times x. 4x is factored into 2 times 2 times x, and 8 can be factored into 2 times 4. In the first term, a 2 and an x cancel out. In the second term, an x cancels out. And in the third term, a 2 cancels out. The simplified expression is 3x minus 2 plus 4 divided by x. Perform the operation and simplify. 2x to the fourth power minus 15x squared minus 7 divided by x minus 3. Use synthetic division to divide. Start by rewriting the numerator with an x cubed term and an x term. 2x to the fourth power plus 0x cubed minus 15x squared plus 0x minus 7 divided by x minus 3. Now write your synthetic division array. Start by taking the constant term in the divisor, negative 3, multiplying it by negative 1, and putting it to the left of the synthetic division array. Negative 3 times negative 1 is 3. Now take your coefficients from the dividend and write them in the top row of the synthetic division array. The coefficients are 2, 0, negative 15, 0, and negative 7. Start the process by bringing the first coefficient, 2, to the bottom of the synthetic division array. Multiply this number by 3 and write it below the second number in the synthetic division array. 3 times 2 is 6. Add the numbers in the second column together. You get 6. Now repeat this process. Multiply 6 by 3. 6 times 3 is 18. Add the numbers in this column together. Negative 15 plus 18 is 3. Multiply 3 by 3. 3 times 3 is 9. Add the numbers in this column together. 0 plus 9 is 9. Multiply 9 by 3. 3 times 9 is 27. Add the numbers in the last column together. Negative 7 plus 27 is 20. The result from the synthetic division is 2, 6, 3, 9, and 20. 2 is the coefficient of the x cubed term. 6 is the coefficient of the x squared term. 3 is the coefficient of the x term. And 9 is the constant. 20 is the remainder. Divide the remainder by the divisor. The simplified expression is 2x cubed plus 6x squared plus 3x plus 9 plus 20 divided by x minus 3. Perform the operation and simplify. T to the fourth power plus t squared minus 6t divided by t squared minus 2. The dividend does not have a t cubed term or a constant term. So write a t cubed term with the coefficient of 0 and add 0 to the end of the dividend. Now perform the long division algorithm. Divide the first term of the dividend, t to the fourth power, by the first term of the divisor, t squared. T to the fourth power divided by t squared is t squared. Multiply t squared by the divisor. T squared times t squared minus 2 is t to the fourth power minus 2t squared. Subtract these terms from the first three terms of the dividend. The difference is 3t squared. Bring down the next term of the dividend. Now divide the first term of this expression by the first term of the divisor. 3t squared divided by t squared is 3. Multiply 3 by the divisor. 3 times t squared minus 2 is 3t squared minus 6. Subtract this expression from 3t squared minus 6t. you are left with negative 6t plus 6. There are no more terms to bring down from the dividend, so this is the remainder. Divide the remainder by the divisor and add it to the quotient. The simplified expression is t squared plus 3 minus 6t minus 6 divided by t squared minus 2. Solve the equation. 3 divided by h plus 2 equals 1/6. Start by finding the least common denominator. The two denominators are h plus 2 and 6, so the least common denominator is 6 times the quantity h plus 2. Multiply both sides of the equation by the least common denominator. On the left side of the equation, the h plus 2's cancel out, and on the right side of the equation, the 6's cancel out. You are left with 18 equals h plus 2. Subtract 2 from each side. 16 equals h. To test whether or not this is a solution, substitute 16 into the original equation for h. You are testing if 3 divided by 16 plus 2 is equal to 1/6. This simplifies to 3/18 equals 1/6. And 3/18 simplifies to 1/6. 1/6 is equal to 1/6, so h equals 16 is a solution. Solve the equation. 2 divided by x plus 5 minus 3 divided by x plus 3 equals 1 divided by x. Multiply each side of this equation by the least common denominator. The least common denominator is x times x plus 5 times x plus 3. In the first term on the left side of the equation, the x plus 5's cancel out. In the second term on the left side of the equation, the x plus 3's cancel out. And on the right side of the equation, the x's cancel out. You are left with 2x times the quantity x plus 3 minus 3x times the quantity x plus 5 equals the quantity x plus 3 times the quantity x plus 5. Distribute and multiply. 2x squared plus 6x minus 3x squared minus 15x equals x squared plus 3x plus 5x plus 15. Subtract everything on the right side of the equation from both sides of the equation, so that everything is on the left side of the equation. Combine like terms. Negative 2x squared minus 17x minus 15 equals 0. Multiply each side by negative 1. 2x plus 17x plus 15 equals 0. This factors into 2x plus 5 and x plus 1. The left side of this equation is equal to 0 when either factor is equal to 0. Set each factor equal to 0 and solve for x. 2x plus 15 equals 0 and x plus 1 equals 0. For 2x plus 15 equals 0, subtract 15 from each side. 2x equals negative 15. Divide each side by 2. X equals negative 15 halves. For x plus 1, subtract 1 from each side. X equals negative 1. Test whether or not these are solutions by substituting them into the original equation. Substitute negative 15 halves into the original equation for x. 2 divided by negative 15 halves plus 5 minus 3 divided by negative 15 halves plus 3 equals 1 divided by negative 15 halves. This simplifies to negative 12 fifteenths plus 10 fifteenths equals negative 2 fifteenths. On the left side of the equation, both fractions have the same denominator, so add the numerators together. Negative 2 fifteenths equals negative 2 fifteenths, so x equals negative 15 halves is a solution. Now substitute negative 1 into the equation for x. You are testing if 2 divided by negative 1 plus 5 minus 3 divided by negative 1 plus 3 is equal to 1 divided by negative 1. This simplifies to 2/4 minus 3/4 equals negative 1. 2/4 is equal to 1/2. On the left side of the equation, the two fractions have the same denominator, so you can subtract the numerators. Negative 1 is equal to negative 1, so x equals negative 1 is a solution. The solutions to the equation are x equals negative 15 halves and x equals negative 1. Solve the equation. 1 divided by x plus 1 plus 1 divided by x minus 1 equals 2 divided by x squared minus 1. X squared minus 1 equals the quantity x plus 1 times the quantity x minus 1. So the least common denominator is the quantity x plus 1 times the quantity x minus 1. Multiply each side of the equation by x plus 1 times x minus 1. In the first term on the left side of the equation, the x plus 1's cancel out. In the second term on the left side of the equation, the x minus 1's cancel out. And on the right side of the equation, the x plus 1 times x minus 1 and the x squared minus 1 cancel out. You are left with x minus 1 plus x plus 1 equals 2. Combine like terms. 2x equals 2. Divide each side by 2. X equals 1. Test whether or not this is a solution by substituting 1 into the original equation for x. You are testing if 1 divided by 1 plus 1 plus 1 divided by 1 minus 1 is equal to 2 divided by 1 squared minus 1. This simplifies to 1 half plus 1 divided by 0, which cannot be equal to 2 divided by 0. This is because division by 0 is undefined, meaning the solution is extraneous, so the equation has no solution. Find a mathematical model that relates u to v when v varies directly as the square root of u and v equals 3 halves when u equals 36. V varies directly as the square root of u, meaning v equals k times the square root of u, where k is the constant of proportionality. Use a given value of v and u to solve for k. 3 halves equals k times the square root of 36. This simplifies to 3 halves equals k times 6. Divide each side by 6. 1/6 times 3 halves equals k. This simplifies to k equals 1/4, meaning v equals 1/4 times the square root of u. When the temperature of a gas is not allowed to change, the absolute pressure, P, of the gas is inversely proportional to its volume, V, according to Boyle's law. A large balloon is filled with 180 cubic meters of helium at atmospheric pressure 1 atm at sea level. What is the volume of the helium when the balloon rises to an altitude which the atmospheric pressure is 75 hundredths atm? Assume that the temperature does not change. The absolute pressure P is inversely proportional to the volume V. So P equals K divided by V, where K is a constant of proportionality. Substitute the given values of P and V into this equation to solve for K. P is equal to 1 when V is equal to 180. So 1 equals K divided by 180. Multiply each side by 180. 180 equals K. Substitute this into the original equation for K. Now find the volume when the pressure is 75 hundredths atm. Substitute 75 hundredths into this equation for P and 180 into this equation for K. 75 hundredths equals 180 divided by V. Multiply each side by V and divide each side by 75 hundredths. V equals 180 divided by 75 hundredths. So V equals 240 cubic meters.